Hello, students of the world, and welcome to another fun episode of Statistics. Today we'll be talking about doing some data analysis using the normal distribution. Don't pay attention to the values I have in here. I am just being lazy and not opening a new window. So if you're interested in the Wilcox-Sain-Rank rank test for differences, maybe you should take demographic data mining. Fun times. For now, we're going to focus on getting some normal probability calculations. There are other videos we have up for normal probability distribution calculations that you can look at besides this one. But this one is geared specifically towards your data analysis assignment number 5. So let's go ahead and get into it. Example number 1. According to data obtained from the U.S. Geological Survey, the magnitude of earthquakes in California is normally distributed with a mean of 6.2 and a standard deviation of 0.5. What's the probability of the randomly selected earthquake in California has a magnitude greater than 5.9? So I'm looking at 5.9 or greater, and I'm going to go ahead and put this into my normal probability calculation. So I'm going to use the probability distribution plot a lot in this video because it's the one I prefer. There are other ways to do this, but I like it because it produces a picture and you can check and double check what you've got based on your picture. So I'm going to go to probability distribution plot, choose probability view, hit OK. And oops, this is on the wrong distribution. So I'm going to need to change this to the normal distribution. And it asks me for the mean, which I know to be 6.2, and the standard deviation, which I know to be 0.5. You don't need the 0 there, but I like to put it in there to make sure I've got my decimal in the right place. Let's go to shaded area. Now, I'm given an x value, a score, and I need to find a probability, so I need to change this radial dot to x value. And notice all these pictures kind of tell you exactly what it's going to be doing. So since I'm looking for values greater than 5.9, I actually want a right tail because there's my score, and I want things larger than it. 5.9 into my value, and hit OK. And there's our video, and notice we get the correct, picture, and notice we get the correct probability. Let's try that again, but we want to figure out, hey, what about a magnitude less than 6.4? So again, we'll go to graph, probability distribution plot, and then we're going to choose probability view. We won't use any of these other 3 buttons, so we'll just always choose the last one. And we're still normal. We've got the correct mean and standard deviation. Let's go over to shaded area, and I want things that are less than 6.4. So let's put in 6.4. The big thing when you're approaching these is to write your probability statement ahead of time so that you know which direction you need to be shading and or which button you should be selecting. We'll hit OK, and we get about, 0.6554. Now we're looking at in-between values for part C. So what probability is it that the random earthquake has a magnitude between 5.8 and 7.1? So we'll go up to stat. I just said the wrong one. Go up to graph, probability distribution plot, probability view, hit OK. My normal, still the same mean, still the same standard deviation. And now I want an in-between value. I want a middle value. So I want over here. So I want to be between 5.8 and 7.1. We'll hit OK. And there's our probability. It always places the probability above the region that you've got, and it gives you the scores down below here. So when we get into E and D, where I'm given a probability and need to find the score, then I'll have to go the other way around. So, well, D is not quite like that, but E is. So in E, we want to know what's the percentile rank for a magnitude of 0.7. So percentiles are a way of measuring you against everybody in the distribution, and your percentile marks which percentage you are at when we count area or percent as everybody who scored worse than you or everybody who's below that specific score. So we're doing area to the left here. That's why we write it as less than or equal to 7. So if you've ever taken a test and they've given you a percentile, that tells you how many people you scored that better than in a percentage. So we're still in the same distribution. And now I want percentile. Percentile is always a left tail. And I want to be less than 7. Apologize that you're seeing my email pop up. And we'll hit OK. And we get about a little bit above 94. So the weird thing about percentiles is we only rank them as the first 2 percentages. So we would round this up and call it the 95th percentile. Fun times. All right. So now let's find what magnitude is at the 90th percentile. So we just saw how to find a percentile based on the score. Now I'm going to go the opposite way. Given a percentage or a area amount, can I find the score that associates with that? So I want to find the score, what would go right here, that I have 90% behind it. So we should expect to be something slightly smaller than 7 because 7 was the 95th percentile. So we go up to graph, probability distribution plot, probability view, everything's the same so far, but our shaded area thing is going to be different. This is based on a score giving a probability. This time I have a probability and I want to find a score. And again, I'm choosing the left tail because we're doing percentiles and those are always left tails. Alrighty, so I'm putting in 90 because that's the percentile I'm interested in. We're going to go ahead and hit OK. And it appears that the 90th percentile is at about a 6.841 or 6.8 if you're rounding. And this choice of rounding to 2 decimal places is because if you're looking back at all of my scores for magnitude, they're all, 1 decimal places. Anyway, let's do example 2. So, let's suppose we're looking at a serum cholesterol level in men aged 18 to 24, and it's normally distributed with a mean of 178 and a standard deviation of 40.7. If one man is randomly selected, find the probability that his serum cholesterol level is greater than 185. So now I'm on a different normal distribution. It's still a normal distribution, same shape, different mean, different standard deviation. So let's go ahead and hit graph, probability distribution plot, probability view. We're still on the normal. I have a different mean though, 178, and a different standard deviation, 40.7. And now we're looking at area greater than 85. Oh, this is on probability, isn't it? Little p's above. So notice how this tells you with the little above pictures that it's a probability, and the x's are on the bottom. That tells you that you're dealing with a score, not a probability. I want to figure out those that are greater than 185. So I want to the right of 185. Let's hit OK. And there's our probability. Woohoo! Okay. Let's do between 170 and 190. So we'll hit graph, probability distribution plot, probability view, and my mean standard deviation are incorrect, and I want a middle value this time between 170 and 190. Let's go ahead and hit OK. And there's our in-between value. It's about 19%, 19.39 to be more precise. And then let's figure out when we will see a cholesterol level below 155, or how likely that is. So we'll go to graph, probability distribution plot, probability view, shaded area. I don't want a middle anymore. I want the less than, which is a left tail. And then I would do 155. You can use these pictures to tell which direction you should be going. We'll hit OK. And that's about 28.6%. You should always include zeros when they're present because that gives you the place value. It tells you this isn't a 1, 2, 3, or 4 that's rounded up to, or rounded down to give you 6. It tells you that's actually a 0. Alrighty, let's find the percentile rank for a cholesterol level of 160. So we'll go to probability distribution plot, probability view, and since we're doing percentiles, we know we're shading to the left, so we'll choose left tail. And we're going to put in 160 and hit OK. And that's all she wrote. So I tried to include the directions on each of these to tell you which way you go and how, but I'm hoping this video will help you since it's a little more specific. And again, when you're doing the percentiles, we got to round up. Well, I hope that helped. Happy studying. Uh-oh, I'm having problems stopping. Ha ha!